Okay, we are working on Algebra 2, and our big deal is we're going to review some of the main types of functions, some of the main types of graphs that we covered in Algebra 1. It's been a long time, and we're going to work on transformations from there. How do we change those, moving them up, down, making them narrower, making them wider? The homework will be based from your book on our first chapter. I think it's a great way of just reviewing. Okay, so let's start off with something kind of easy. So this is just, we'll call it Algebra 1 graph review. So what my expectation is for your notes is that you guys are taking notes, writing everything I write, adding some extra notes of what you're thinking to help process what we're doing, as well as keeping these notes in a safe place. For instance, either in a spiral notebook or in a 3-ring binder. And the homework and notes work, notes, homework, notes, homework, notes, homework. So every time you have notes, you have homework right after. Okay, our first function is a constant function. We'll call it a constant. And that's going to be y is equal to k. Where k is some constant. And what I mean is this could be a graph of y is equal to 3, y is equal to 7, y is equal to -2. These are all constant numbers. It is not changing. There is no variable on that side. So we think of this as this. If x was 1, y is 3. Darn it. If x was 2, y is still 3. If x was 5, y is still 3. Man, you're constant, so you never change. So no matter what x value I plug in, we end up with a y value of 3. So we graph it as 1, 2, 3. And then my graph will look like this. A horizontal line that never changes. If you have $3 in your pocket and you never spend it, and you never make any more money, you still have $3. $3, $3, $3, $3, $3. Okay? So that's the idea. This isn't a variable. It is not changing at all. It is a constant number. So if y was 7, if x was 1, y would still be 7. If x was 2, y is now 7. And if x was 5, y is now 7. This is a function. This totally works. And this tells us a relationship that there is no change. There is no growth. A lot of you guys are freshmen and you guys are growing. You're going to get taller. And some of you guys are juniors, you're done. So you guys are going to be at a constant height. Some of you girls, you might say, I wish I was taller. I'm sorry, you're done. You're now at a constant height. At least you made it to 5 feet, hopefully. Okay, we can write 7 here to make my graph a little easier. Remember, these graphs are my graphs. So if I want to just make a line and call it 7, fine. I don't need to do 7 tick marks. This is my graph. As long as I can understand what I'm drawing, it makes sense to me. This is a constant graph of 7. No growth, no loss, no quote-unquote change. And the last one at -2. If x is if x is 1, y is -2. If x is 2, y is still -2. And if x is 5, y is still -2. Right? If you owe your friend $2 and you don't pay him back, you still owe him -2. That's a constant. So one thing that we realize, I want to say, is this variable k in algebra? It's going to be a popular variable. And this is what we call our vertical change. This helps us say, hey, if my k value was larger, this graph would go up. If my k value was lower, this graph would go down. And sometimes we might call this a vertical change. We call this, another term is vertical shift. I'm calling this a vertical shift. K for us, let me finish drawing this graph, we said it's going to be -2. down here. So K for us is our vertical shift. So lost the C. Vertical shift. I'm going to illustrate that for you real quick with my Desmos calculator. I'm going to include a link to the Desmos calculator in the homework. And let me get there. Now, I've included a lot of different graphs if you see on my left-hand side, but I'm referring to the first one, y is equal to k. Now, if you look at the bar right here, see how it says k is equal to 0? So we have a graph that's kind of buried here, but k is equal to 0. And I'm going to change this k, and I'm going to watch it grow. You guys ever watch Power Rangers? Make my monster grow. So I can move it up and down based on this k value. Now, if k was 1, this graph is now, oops, come on. If k was 1, now this graph is horizontally not changing at k is equal to 1. Or, let me go ahead and write this a little differently on the right. Give me a sec. Oh, this looks terrible. I hate when it gets stuck. So for this example, for y is equal to k, so y is equal to k, is instead k, we said k was 1. So this graph that you see right now is a graph of y is equal to 1. What if I say k is 2? That's my next content. Y is equal to 2, and the graph is a little bit higher. What if k was 3? Doesn't the graph get higher? K was 4, k was 5. The idea is this, we call this a vertical shift because it moves my graph up and down. So pretty much for all the graphs we learned in Algebra 1, they had this k value. They might have called it b for a line. Remember y equals mx plus b? That was my vertical shift actually. And we'll see that in the illustration coming up. So instead of using the letter b, this is the idea of k, and then move my graph up and down. Okay. All right, so let's talk about a line that does change, that is not constant. So we have this line equation, y equals mx plus b. This is super popular. We call that a line equation. And we had different parts. We had m, which stood for the word slope. Another way of looking at slope was an easy way of saying rise over run. And rise over run was just another fancy way of saying how much you rose, how much did your y change whenever your x changed. And this is a fancy way of saying delta. And delta in math is another way of saying a difference, a change. How much did the y change versus how much did the x change? So if the x changed by, let's look at an example of slope. If your m was 3 and your run, so 3 over 2, that means your rise was 3 every time your run was 2. Oops. Your run was 2. So just give an example. Every time I went 2 spaces over in the x direction, I must go 1, 2, 3 spaces up in the y direction. It's almost like this ladder. It's forcing your ladder to grow, to change by that much. But if I change my m to 5 over 2, this again is my rise and my run. Hey, this is a bigger change. So every time I went 2 over, 1, 2, I must now go 1, 2, 3, 4, 5. And now it's an even steeper change. This is really important because you can almost think of this as your pay. If my pay was small, I wouldn't grow that much. If my pay was high, my change was high, I would grow a lot more. So we're going to look at this on the aspect of shifting. So I'm going to rewrite this equation slightly. We're going to write this as y equals mx plus b. And we're going to look at it on a slightly different way, in the transformation way, of y is equal to a x minus h plus k. And the reason why I'm writing it this way, because the other two types of graphs, they'll look exactly like this. So I wanted to show you guys a couple things that happen when I mess with my h and mess with my k. When I mess with my h, look who it's picking on. It's picking directly on x. So the h affects what happens to x. So if I add h or I subtract h, it pushes the x value around. In this case, it moves it left and right. So let's go and see an illustration of that. Oops, wrong one. Okay, let's go and take a look. So here's my line. If I move my h around left to right, see, it's the exact same line. The line is not growing or shrinking any differently. I'm just moving it from left to right. Let's follow up with the k value. If I'm moving my k, remember we called our k our vertical shift, that moves it up and down. It is the same line, just moving up and down. But we normally don't think of lines this way. We think of lines simply as, y is equal to mx plus b, because the m and the b is a interpretation of what we're doing here. And we all find that y goes to mxb is easier. So that's a go ahead and reiterate what happens for m and b. Y is equal to mx plus b. And again, we called the m, the slope, how much I'm changing, and the b value, we're going to call our y-intercept. So I'm going to give us an example here. So if I see a line that just says this, y is equal to 3x. First indication is this. You have to notice that this is just a plain, simple x. It is not x squared. It is not absolute value of x. It is just simple x. So the first thing you should say is this is going to be an easy line. An easy line. Every time you see x by itself, no fancy stuff around it, it is going to be an easy line. What is the b value? The second thing you should spot is what is the b value? The b value, my y-intercept, is there a b value here? Nope. So we can easily say b is 0, and that's 100% okay. We were okay with that in Algebra 1. The next thing we look for is the slope. The m is the number right in front of the x. The number right in front of the x here is a 3. So that's my m value. So m is 3, and oftentimes we wrote it as 3 over 1, which helped me later in graphing. 3 over 1 is 3, but rise over 1 helps me talk about it. So this is going to be rise over run. So when we graph it, we say my starting value is first graph the b. Since this is an easy line, we're just going to graph our two main points, our y-intercept, which is 0, and my slope, which is rise of 3, 1, 2, 3, for every run of 1. To talk about the same type of graph, if I say y is equal to 3x minus 2. So I want you guys to make a guess right now, and I'll make a quick poll. What do you think? Actually, no, I'm not going to do a poll. But go ahead and think about it. What happens to that negative 2? What does that do to my 3x graph? Does it add 2x? Does it subtract 2x? Would this graph make it go to the right, up, down, or left? So in general, if I took your salary and I minus 2, what happens to your bank account? Right? All these inferences that we come up with, are applicable to our everyday lives. So let's look at our characteristics. 1, this is an easy line because this is just a simple x. 2, our b value is -2, so our vertical shift is 2 spaces down. And our slope has not changed. It's still going to be 3/1. So I'm going to go ahead and draw this back on our previous graph that we did already. So my b value is -2. So let's start off 1, 2 spaces down. Put a dot. And then when we rise, 1, 2, 3, and over 1. And you should end up with what we described as parallel lines. Parallel lines are lines that have the same slope. The only difference between these two lines is that I have moved the second line, my red line here, down 2 spaces. There's a vertical shift. And that's all we want to be able to describe. What does each of these characteristics do to change my graph? Now, let's talk about that 3. We talked about the 3 already. The 3 was my rise and run. There's a couple of different ways of talking about what this does, the a value, in this case, the m value. In other graphs, it's called a vertical shrink or vertical stretch. In this one, we're just going to say it changes the slope of the graph. Okay, m is just the slope of the graph. We don't talk about in x squared that the a value is the slope because it really isn't the slope anymore. Okay. So how would I describe the numbers that would affect this graph? The 3 increased the slope to 3, and the -2 shifted the graph down 2 spaces. So the m, which is 3, increased the slope to 3/1, and the b value, the -2, shifted the graph 2 spaces down. Okay, so let's keep going. The homework problems that you guys will see today are going to be in these standard forms. And they're going to ask you, hey, what happens when I stuck a 3 on there compared to the easy graph, x? Okay, let's do parabolas now. Now, parabola graphs are defined by anything that's x squared. That's the highest exponent is x squared. And our standard version for it is y is equal to ax minus h squared plus k. This looks pretty fancy. It looks like it's a lot of stuff. But h, we said, was our left and right shift. And we're going to add a name to that. This is going to be our horizontal shift. And this will be a lot more obvious with parabolas compared to lines. Our k, we said already, we called it our vertical shift. And our a, very similar to our slope, we're going to use a term. It's either going to stretch or shrink. I'll say this, a vertical stretch or shrink. Yes. Vertical stretch or vertical shrink. And there's other names depending on the book, whichever one you want to go by, but there's other ways of doing it. So let's see our basic x squared graph. if I say y is equal to x squared plus 1, which characteristics have been changed? The a, the h, or the k? So think about that. Compare that to y squared, y is equal to x minus 1 squared. So the big difference is when I affect the outside or I affect the inside, that's where you get your h and k from. That's how you tell the difference. If I affect something from the outside, that is a vertical shift. It will always be a vertical shift. If I affect something before, see how this is before I square it, according to order of operations, I've affected the h, which is my horizontal shift. So let's go ahead and graph these two separately, and we can see simply their effect. So I'm going to create a table here, x and a y table very quickly. We'll say the numbers, simple numbers. We'll say -1, 0, and 1. Just 3 numbers. And that's enough for us to see what this graph, what +1 does to my graph. So just on the side note, sorry, let me write this also. What happens with a parent graph? This is what we call the parent graph. Parent graph of x squared. Y is equal to x squared. Let's look at the numbers. X and y. 0, sorry, whoops, not 0. -1, 0, and 1. So if I plug in 0, what is 0 squared? Right, it's going to be 0. What is +1 squared? That's going to be 1. And what is -1 squared? Negative times negative. Let me just write it out, sorry. -1 squared. That's going to be 1, 0, 1. And when I graph this graph, oops, use the wrong color here. Our graph is going to be when x is 0, when x is 0, y is 0. When x is 1, y is 1. And when x is -1, y is -1. And the parabola looks something like this. So we just graphed the basic x-squared graph. And the basic x-squared graph pretty much looked like this. I'm going to graph it on this graph real quick, lightly. 1, 0, sorry, 1, 1, 0, 0, and 0, -1. And our graph kind of looks like this. Okay. Now, let's go ahead and plug in our same exact x values to this new altered version, the version with a k value. And we know it's k because k is outside the x squared. Okay, let me point that out. See how k is outside the family? It got kicked out. K is outside the family, while h here is inside the squared. So that's a big difference. What happens outside and what happens inside. And that's the thing you have to memorize. What and where and how does it affect it? So let's go ahead and fill out the problem. If I plug in 0, it'll be 0 squared plus 1. 1 squared plus 1. -1 squared plus 1. Again, I'm just plugging this equation using the variables x's, 0, 1, and -1. When I crank out the math, -1 squared is +1. 1 plus 1 is 2. 0 squared is 0. 0 plus 1 is 1. And 1 plus 1 is 2. Let's go ahead and graph these values here. When x is 0, y is 1. When x is 1, y is 2. When x is -1, y is +2. So when we graph this parabola here, What is the only difference in this parabola? The only difference is that we got shifted up and down. Now I'm going to go ahead and illustrate that with you. Illustrate that for you. So our parent graph x squared, we know will always look like this U shape, right at 0, 0. If I shift it vertically with this k value here, it will move the graph up and down. So let me go ahead and show you guys this. And again, I'm going to provide you this link. Now, if I shift the k value, it just moves it up and down. It doesn't affect anything else about the graph. It doesn't change how the graph is curved. It doesn't move it left and right. It just moves it up and down. I see, I'm just changing the k value. It only moves it up and down. That's all it does. Now, if I move it h, that moves it left and right. So if I want to move the graph a little higher and a little bit to the right, I would have to change both the h and k value. But if I want to move it a little bit lower and a little bit to the left, to do that, we would have to change the h and k value. But the idea is that as long as the a value doesn't change, the graph is still going to be, have the same curve. Now I'm going to trip it now. If I move my a value though, come on. If I move my a value, come on. If I move my a value, that shrinks or stretches my graph. It shrinks or stretches my graph. Now I want to pause here real quick. If you look at this, if you look at my a value, please look at my lower left-hand corner. Oops, darn it. The button doesn't stop working. If you look at my a value, this is negative. So when a is negative, it gives you a graph that's flipped upside down. It's flipped upside down. If a was positive, oops, now we came back. If a was positive, we'd be on top, pointing upwards. And if a was negative, it points it downward. A simple symbol of a negative could give you positive income, or it could give you negative income. Okay, let's go back to the notes. So let's do the same thing over here. The whole goal is to show you guys that there's a difference between where I put numbers, whether I put it inside the square or outside the square, and that changes the horizontal or vertical shift. So let's go ahead and finish this one. Real quick, x and y, plug in the same numbers, -1, 0, and 1. And we're gonna chart it out. I'm gonna draw my original 1, 1, 0, -1, 1. This is from my parent graph of x squared. I'll use dots here. Dot, 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 dot. Okay, that's my parabola, my original x squared graph. And I'm gonna go ahead and plug in the formula x, which is now going to be my first number, -1. It'll be -1 minus 1 squared. 0 minus 1 squared. 1 minus 1 squared. And let's look at what's the results of the h change. -1 minus 1 is actually -2. And -2 squared is 4. -1 squared, 0 minus 1 is -1 squared is +1. And 1 minus 1 is 0 is going to be for us a 0. I'm going to do one more for you guys to help us out. I'm going to stick a 2 here. And the reason why is because so you guys can see the curve coming back up. So 2 minus 1 is 1 squared equals to 1. Now I want you guys to make sure you guys see that these numbers are totally repeating. Look at the 1, 0, 1 here. look at the, whoops, look at the, down, right here. Darn it, lost it. Look at the 101 here and the 101 here. These are the same exact numbers, but they happen at different x's now. It got shifted in time. Now let's go ahead and graph this. At x is 0, the y value is 1. X is 0, y is 1. When x is, wait, yes, that's correct. When x is 1, y is 0. When x is 2, y is 1. And when x is negative 1, y is now 1, 2, 3, 4. We have our parabola. Sorry. It's the same parabola, just shifted over to the right. Okay, so that's recap. If I have a change on the outside here, this is going to be a vertical shift, up or down. If k is positive, we move it up. If k is negative, we move it down. If we change it inside the squared, that changes it left and right. So let me go ahead and show you this relationship. If this number is, see, there's a problem here. It says x minus 1. So if we look at the original form, there is always a negative sign here to begin with already. Everyone see that? There's always a negative sign here already to begin with. So h here isn't negative 1. It's actually positive 1. Because we want the negative to stay. So I'm going to go through some quick examples because this is a big deal for us. Some quick fire examples. If I write y is equal to x minus 3 squared, what is my h value here? Is it going to be positive 3 or negative 3? Positive 3 or negative 3? Remember, the basic formula is x minus h squared plus k. The negative is already there. The negative is already there. So if the negative is already there, this is going to be a positive 3. That means we're going to describe this as a shift to the right. If I write y is equal to x plus, nope, let's do a negative again, negative 7 squared. H is positive or negative 7. Remember, the negative already has to be there. So h is positive 7. So since it's a positive, we're going to shift to the right. A shift to the right. To demonstrate this, once again, let's go to Desmos real quick. So we have our parabola at 0. And if h is positive, take a look here, I'm making h positive. We shift to the right. If h was negative, we shift to the left. If h was positive, we shift to the right. If h was negative, we shift to the left. If k is positive, we go up. If k was negative, we go down. All this stuff is going to be the same. Okay. Now, this part is intuitive. As long as you can figure out what side is, or what is the value of h. Let's do a couple more. Y is equal to x plus 2 squared. So what is h here? Since we said we have to have a negative, I'm going to rewrite this to help myself start off as a, well, doesn't a negative times a negative become a positive? So make sure you take a look here. This is the expectation that you put a negative so that when you mix a negative and negative together, you end up with a positive here. So if we end up with a positive inside the parentheses, that means the h value is going to be negative. And this is a shift to the left. A horizontal shift to the left. Let's do this again. If I say y is equal to x plus 5 squared, this is a parabola. The squared automatically tells me it's going to be a parabola. So we have to make sure this is our h or k. This is our h. H is going to be a negative 5. Because again, we are supposed to have a negative. This is supposed to be a negative. So how do we make it a negative? Well, it's because originally our h was actually a negative 5. And this is going to be a shift to the left. Okay, just give me 2 more minutes and then we'll be done. Now, the last graph here, and you guys won't really have to graph it. You just have to decide what happens. You won't have to graph it in the homework. You just have to decide what happens. You can use a graphing calculator to graph it. And this is absolute values. And these are what we call little V graphs. But the thing is, if you can do parabolas, you can do absolute values because it's exactly, oh sorry, not exactly, but pretty close to the same formula. Our formula for absolute values are A, absolute value of x minus h plus k. In contrast to what we just wrote before, we wrote before as y is equal to a x minus h squared plus k. This is a parabola, and this is a absolute value. Look at the two. Don't they look pretty similar? They just changed what? They just changed the square and parentheses for an absolute value sign. Now we can go into more detail next time, but if I wrote this, y is equal to x plus, sorry, not x plus, x minus 3. What do you think happens to this graph? What do you think that negative 3 what does to this graph? Would that negative 3 be considered h or a k inside the absolute value? An h or a k inside the absolute value? H would be positive 3. So 3 is an h value because it's inside the absolute value. If it was outside, we would call it a k. So what we're going to do here is we're going to say, hey, since we know h is my horizontal shift, this graph here, it's the same graph except 1, 2, 3 steps over. The graph got shifted by 3 spaces. No, too much. The graph got shifted by 3 spaces. If I wrote y is equal to absolute value plus 2, is that an h or a k value? H or a k? This would be a k since it is outside the graph. So we can describe this, we can draw it right now. It's the same V graph except it's 1, 2 spaces up. Because it's a k, it got shifted up by 2 spaces. Now, this is our last example. What if I mix everything together? Y is equal to x minus 3 plus 2. So we're mixing our first example, our second example, to get our third example here. So what happens when I mix them both together? We make sure we identify all the parts. The h is going to be what? 3 or 2. The k is going to be what? 3 or 2. We have to make that conscious decision first. H will be 3 and k will be 2. H is going to be positive here because we have to keep the negative sign there. So what we do is, fine, move over 1, 2, 3 spaces to the right. And we're going to move up 1, 2 spaces up, put a dot. So we moved over to the right 3 spaces and up by 2. And this is our graph. And we would describe it as we had a horizontal shift to the right by 3 and a vertical shift up by 3. Sorry, up by 2. For some reason, I just got stuck there. Up by 2.